This conference will now be recorded.
Welcome to Terraform Basics. In this session, we'll talk more details about what is Terraform and how we can build the different cloud stacks. So we have different options to work with the stack. So you can work with the AWS stack, you can work on GCP, or you can work on Azure stack. So depends on your requirement, or if you are working on multi-cloud environment, then you can have multiple stacks. So configuration management is a key area. So Terraform is infrastructure as a code where you can configure only infrastructure level. You cannot make the server up and running. That is not the in control of the Terraform. So the web server or database server, something you want to bring it up, then again you need to depend on the configuration tools such as Ansible or Puppet or Chef, something like that. But beyond that one, so whatever the infrastructure is required, like a private network which you want to build and subnet which you are required, or if you're going to create the servers, load balancers, etc., or access for the internet, IAM, so identity access management. So if you want to create users access, all those things, security groups, these things we can consider as a configuration management under your Terraform. So what you need to know for in Terraform and how we can proceed further towards the goal as a Kubernetes cluster. So Terraform also supports the containerization, and our ultimate goal is to work on the Kubernetes cluster. Okay, so what is Terraform in a precise way or simplest way? Here, briefly, Terraform is an infrastructure management tool. It is made by the HashiCorp. So HashiCorp is a company which is having almost 5 different components from the HashiCorp. So if you look at the HashiCorp, Vagrant is most widely used, and the next one is this one, Terraform. And in between Vagrant and Terraform, we have Packer. That is a internal tool. It is helpful tool for the Terraform, or it is same thing will be used in the Vagrant as well. So it is a package. It is an infrastructure packing tool. So if you want multiple things of the same kind of thing, then Packer will help. Terraform is used to build, change, and versioning. So you can write a code, any program, any text file, so that we can store. And whenever you are storing into the version control system like GitHub or GitLab, there you can store that as a with version. And infrastructure safe. So when you're going to work with the infrastructure, to build infrastructure manually by clicking each one, it might take some number of days or some hours approximately. So those things will be very simplified with this infrastructure as code. And it is very efficient if you compare with the manually creating anything. So if you go on AWS, creating one instance, EC2 instance, it hardly takes 10 minutes to build the instance. Whereas this Terraform, if everything is ready, one instance will be provisioned within 1 minute or 2 minutes. So it reduces within minutes. So that is if you are connected from the AWS to AWS communication. So you want to work, you want to provision EC2 instance, and you already have the instance. From there you want to work, then it is fraction of seconds to build the instance. So how you are working, the connectivity makes the difference. Otherwise, it is very fastest or efficient way of building your infrastructure. So Terraform, how we are going to build, when you are going to use a Terraform, it is having tools, and you are going to tell you are going to use the resources. So when you are going to managing the cloud infrastructure like AWS, or if you are working on the Azure, So you are having storage components. So AWS is having S3 bucket as a storage resource. So we can create a bucket and we can give the authentication how you want to access that one. So you want to use only for the private, that is only for your project you want to access that one. So all these are you need to choose in the wizard when you run the creating the S3 bucket. So all those steps we are just writing in a couple of lines, and it is going to run whenever you are just say um, with the simple language, Terraform language, you are defining all these things. So once you define the infrastructure desired state, then you're going to run with the plan, and it is going to tell what are the possibilities. The syntax or whatever you are given is semantically correct or not. So plan will decide that everything what you are given is correct. Then if syntax is ready or good, then we can go for the apply. So this is actually actionable thing. So this will work, this will connect to the AWS, and then it is going to work on the AWS cloud. This is one example. So similarly, you can work with Azure. Similarly, you can go for the GCP. So once you run Terraform apply, it is going to work corresponding cloud platform and execute the desired resources will be created. So this is a one example, deployment of a configuration, what you need. If you complete the test, if you don't want to further this infrastructure, you want to save some amount on the your cloud, then immediately you can wind up, close it, destroy it. So whenever you want, again you can just apply, you will get it. So that is a fastest life cycle. You can refresh this environment at any point of time. Once you build, that will be reusable. Okay, so that is the power of Terraform. So if you are going to work on the different cloud platforms, each one is going to have one different stack. So if I recommend to download your code editor. So the code, Visual Studio Code is the best code editor, and other alternative Atom. So these are the best tools for working on the Terraform. If you are having Windows platform, these are the best options, and even MacBook also supports Visual Studio Code. And syntax highlighting is the most highlighting thing which you can get it from the both of them, Atom editor and Visual Studio Code editor. Then once you start working on this project on Terraform or building something on Terraform, so you're going to work on different cloud platforms. Each one we are going to call it as a stack. So Terraform either translating your existing stack. So you are already having some AWS stack. You can get everything. You can convert that one into a Terraform code. That is reverse engineering. It takes time to build everything working, but it can happen. And in a opposite direction, that is you are going to write the code, and then your stack, whatever the stack you require to run one application on a cloud. For example, if I'm going to have a LAMP infrastructure requirement, so it is going to work on the Apache LAMP. So where you're going to have the database and PHP and Apache web server. So all these are on different VMs we want to run, and all these together have the network. They should have a capability to connect with each other. So entire environment is usable for one particular application. And if there is a need of expansion, it should be very simple. So that is what we are going to get from the stack. So one stack will able to deploy one application, complete application from the scratch to till the application readiness. You just need to do deployment after that. So if you are working on a Tomcat kind of thing, you're writing one JSP file, something web application, or If you're working on nginx or Apache web server, HTTP web server, then you are going to write some HTML code. Developers need to modify that files. So these are the different where what is actually reusable thing, or where you have to keep changing or continuously changing. These points we're going to use as a volumes. So we need to understand the structure according to the application, what kind of application you need to deploy on the cloud. So Terraform will use a TF file, .tf file, it's an extension, and then Terraform tool will be working for us, and we need the user credentials to work on this. So user setup is of most important thing. So if you're working on AWS user you need to create on the IAM. Okay, so once you create the IAM user, and then you associate with the policy permissions, then we can access the AWS cloud. So the using that cloud access, you're going to have the access key and secret key. Then you can provision the instances. You may create the EC2 instance. You can work on the VPC, or you can go for the subnet, or you can go for the elastic load balancer. So there are a lot of resources which you can build from the Terraform. Okay, so Terraform, what it do? It maintains, it manages the cloud resources like virtual machines or servers like database. In AWS, we are going to have DynamoDB or Oracle database. So you can also have the networks, and you can also have the S3 storage, Route 53. So these are all different the resources which we can create from the Terraform. So in all centralized set of code, everything you are going to write in one code. That is what we are going to call as a stack. So it is very simple and a command line program you can run. Okay, so I just downloaded this Terraform exe file, and I keep in the path in my laptop. So I can run that Terraform command so that I can get the EC2 instance on the AWS, my AWS account. So that is how it is going to work, and we'll see that in demo. So Terraform configuration management, you cannot really change anything running servers. You cannot stop, you cannot deploy of the web application, something, you cannot do that. So configuration management tool, you need to depend on the Ansible or Puppet or Chef. That is another next level. So it is possible to run a tool in Terraform feature called provisioners. Providers are different, provisioners are different. So remember this point. So configuration management will work like Ansible will work as a provisioner. So if you want to use Chef, then provisioner will be Chef. So that level of deep level we will discuss in next sessions. So beyond configuration management, what else we need after that? So it is to deploy. You need a pre-made server images. So you don't want to waste much time. So you are going to use the already existing images that in AWS we are going to call it as AMIs. So ready-made images which will be built for one project. So in our project, in your project, you are going to use, but for testing purpose, we are going to use free tier examples. But in real-time projects, we are going to use a specific server image will be used. So in Terraform, you need to create first base image. HashiCorp tool is used to configure management, and that is called Packer. So HashiCorp is having a separate configuration tool, just like other tools, third-party tools. We can also use Packer tool. So load balancer is set up here. You can do with the tolerating the cycling server instances. So you want to start and stop everything that we can do, and we can control load balancing, where the entry should come, which IP address should we go, subnet, etc. That we can define in the Terraform. So when you're going to work on that Terraform, so you're going to work with your laptop or your the serverless. Terraform is a serverless programming. So where you're going to work on one machine, from there you can run, you can provide, you can use GCP, you can use Amazon, you can use Azure clouds. So you should have a basic knowledge about these clouds. So you should have a basic familiarities. What is EC2 instance on AWS, or what is virtual machine in Azure? What is a machine in Google? So these are all different terminologies. Every cloud they are using in different, but at the bottom level, you can understand they are finally getting one virtual machine. That may be Ubuntu, that may be CentOS, something like that. So Linux BIOS you want to use, so that is a basic requirement for any project. Okay, so if you are going to see, want to work on more on this Terraform, first you should also have Git commands basic understanding. So how to pull, how to use the clone command, and how to get something from the internet, from the GitHub. And then basic Linux commands, Unix commands, that will also help you. So these are the basic requirements. And if you have a desktop, or if you have a system in your project, in your office, from there you can work on these two tools. Okay, so once you finish this basic understanding, then we'll start working on the next level. In the next level, we are going to work on the Terraform is going to manage containers. Terraform is going to work with the Docker containers, and then next level we'll go for the Kubernetes. So Docker, once we finish, then we'll go for the containers will be pushed to the container cluster, that is Kubernetes cluster or Kubernetes orchestration. So you could even use the Terraform to provision Kubernetes cluster on any cloud providers. It may be EKS, or it may be Google Kubernetes, or it may be Azure Kubernetes platform. So you can use any one of them. So this is the best tool which you can use as an infrastructure evolving tool. So Terraform is one declarative language. It is going to describing what infrastructure you want intended to make available for a project. So there are different steps, different stages for every project that will be achieved, and it is used client only architecture. So it is not having any server. So remember that it is a serverless programming infrastructure. So let's have a demo hands-on on Terraform. Okay, so in my system I just made a simple setup. So two environment variables I have defined. So if I'm going to say here yeah, so I have two environment variables. One is AWS access ID, and another one is AWS secret key. Okay, so how I have these two. So if you just go to the AWS, and then in your services type the IAM, and you will be getting the identity access management tool. Yeah, so you just try to create a separate user. Just so once you log in, then go to the same step there. IAM. So here, if you click on the user, then you can add a user. So adding user is very simple. You can just name. So you can give a name like a test user. Okay, so you can name as per your requirements. So development user, test user, QA user, like that you can create. And then access type, you're going to use programmatic access. Okay, so here we are going to use that programmatic access. Then click next. So I have defined one uh, group, so which is having the full access to my EC2 and S3 and DynamoDB, so which will be further we are going to use. So I just created this group, and so it is associated with this permissions. So it is having almost 5 different policies attached to this one. Okay. So similarly, I'm going to use this. I'm using the same set. So here you can see just last updated attached policy. Actually, it is having 5. So you can see all the 5 policies which are attached. Okay, so these are the 5 policies, but here I'm just testing for the EC2 full access at the moment. So just go for the next, and then you can say what is this user. So user testing Terraform. So you can name it and use a tag. So once this is created, test user is created, then here it is in review. Then we are going to create the user. Click on the create user at the bottom. Blue color button is there, and here you got the user created. Okay, so this user is going to have access key, and it is going to have the secret key. So these two are required when you are going to work with the Terraform. So you can work with the these users how you want to create. So I've just created the similarly one demo user, and I have used here. So this is the demo user I have just associated with the 2 environment variables I created: AWS access key, AWS secret key. So just now how we got that, so same thing I got there. Okay, so then I just created one folder. Inside that, let me just check. So here I have main.tf. So if you're going to see main.tf, the file consists of provider and region. So I'm at Asia Pacific region, south side. So Mumbai is my nearest place. So I have chosen AP South 1. So if you just go to your AWS account, and you can see that one on your page. So the global, you can see where you are associated, what is the bracket. So within the bracket, you can see that one. All right, so I just close. Um, all right, so that is actually makes one region information which we can enter. The next thing is the next section is about the resource. So resource is a section where you're going to write about what you want to create. You want to give an instance. You want to create a AWS instance, EC2 instance. And when you're going to create the EC2 instance, you can name that instance. You're going to name an instance. To remove it is useful. So when you're going to use a AMI, so what is the name of the AMI? This is available on your AWS. So if you just go to services and search for the EC2, okay. So in the EC2, just try to search for the AMI names. There are different AMIs which are associated with the different regions. If I'm working in East US, that will be different. And if I'm working in India, it will be different. If I'm working in UK, it is different. So AMIs are different available numbers, or it is IDs are different. AMI IDs are different. So I'm just going for the running instance. So I don't have any instance. I'm just clicking the instance run. And then if you look for this search, in the first step, you can find the AMI. So I just want to go for the Ubuntu. You can go for the CentOS or you can go for the Red Hat. So as per your requirement in your project. So I'm just going with the latest version in the available list. So 18 is the latest and 16 is the older. So I'm just going with this option. And there is again two options, 64-bit x86 and ARM. So ARM is again, it's not free. It will be, it is going to cost for you. So check that option and then click that. So when you're going to click, you're going to have the option to know about this particular instance. So here you can see T2 macro. This is the type which is freely available, and then instance details you can see here. Okay, so so using wizard, we don't want to go further. So just canceling here. You can see this is a ID, so which we are going to use inside the Terraform code. So there you can just simply say here cancel, and you can just copy that. And then instance type is T2 macro, you have seen there. And then if you want to make the name, what is you are going to create. So I'm going to create from the Terraform EC2 instance. So that's why I'm given the name as a Terraform EC2. Okay, so this is a simple Terraform code which we can create, you can write. So then you can check this syntax is correct or not. Terraform plan. So if you are working first time in your folder, then you have to run Terraform init. So it is going to initialize your project and it is going to check. So as per the provider, means if you're going to see main.tf, the line, first line, what you are having, that is a provider. So this AWS CLI will be downloaded and it will be available in this Terraform. So in the Terraform directories, subdirectories will be created automatically. Okay, so you can have one separate file called AWS. So AWS executable file will be available so that this provider will be automatically connected to that. So AWS CLI, Azure CLI, GCP CLI, these are the different things which automatically downloaded for you by the Terraform. You don't need to do anything. Okay, so if you see, there is a hidden folder created. So in this plugins, as per the provider, it is going to have Terraform provider AWS. So this is automatically downloaded, available because of this initialization of the project. So if I'm going to use a GCP or if I'm using the Azure in place of this one, then that will be according to that cloud. We are going to get this exe file inside this. Okay, so this is the path where you can see. Okay, so here we have the main TF, and the next command, Terraform plan. So it is going to check, is there any TF file in the present directory? There is one TF file, main.tf. So that one, it is going to verify the syntax, everything is correct or not. So if it is the syntax is everything is good, then it is going to show you two types of symbols. Here, every line it is going to check, and it is going to show a plus, means it is going to create, it is ready to apply. Okay, so sometimes you are going to have minus, means in the code you remove something, or in the Terraform file if you want to remove, for example this tag you don't want to, then it is going to change. Let me just do code the main.tf. So in the Visual Studio Code you can edit this one. So I'm just removing this tag. Without tag also you can run the program. So let's see, if I remove, what is the difference it is going to identify from the plan. So in the output, in the plan, you can see, you can see that that section is no more, and it is removed from this list. So whatever is available, which you can provision, and you can see that difference. Okay, so I just want to show you here what are the changes. So we have one add, all are in add sections only. So if something is added, you are going to get in change. As something is you want to delete that EC2 instance or something, then you are going to get the destroy option. So I just go into the console. Okay, here we don't have any instances, no EC2 instance. Okay, so here Terraform apply. So when you run the Terraform apply, it is showing the same what plan is shown, same thing. So plan is just for checking the syntax. It is just like compilation. So here if you say yes, then it will connect to the AWS with the access and secrets what you have provided. The credentials will be used to create. So it is going to create the AWS instance, and the name of the instance is this sample tf1. So that will be what we have given in the Visual Studio Code, what we have launched. Okay, so here whatever the name you have mentioned, the resource, this will be created, and based on what, this is the AMI. So if AMI you are using, mine is different, so that depends on the which region you belongs to. So these are the important aspects we have to check. All right, so in the syntax wise, okay, so if you see here the output, the apply completed, a resource one is added. Okay, only one resource we have created, that is EC2 instance. So just refresh. Yeah, so it is created, one instance is created, and it is not having any name. So this name, if you want to add, that is a tag. So if you add the tag, then it is automatically changes. So so within fraction of seconds, it is able to connect and build this instance, right? So I just want to edit the same here. I just want to add this name tag, and then check this, apply. Again, it will run the plan first, and then it will go for the apply. So it is going to compare with the ID, so which is already in existing. So every time, whenever it is existing, it is going to executing the Terraform. Then it is going to check. So modifications completed, and it is changed. So the Terraform we have changed. So when it is changed and it is again, you can see here, refresh, you can get the name what you have. And this is up and running. So existing resource you can simply modify. You're not taken that much time to launch how much it is first time. So that is how we can work with the Terraform and different providers, different resources we can build and can proceed on that one. So far you have learned about what is provider, what is resource in a Terraform code. So this is what HCL. So Ashika configuration language. Yeah. So Nagesh, you have any questions so far?
No, I'm good.
Okay. So you have access AWS. Shall we do it on your system?
In what
Would you like to do the setup, account setup, AWS setup from your laptop?
I don't have my local setup. I'll do on my company account.
Okay, fine. So yeah, from my end, this is all for today's experiment demo. So from yeah, alternate class. So another class would be on Saturday, Nagesh.
Okay, sure.
Okay. Yeah. So we'll talk further, and yeah, we can proceed on that. And you have any other specific requirement customizations, do let me know.
Sure, yeah.
Okay, thank you guys. Thank you all. Bye.